Hello everyone, today we will be going through every single graph that you will need up until year 12 with examples today. So we'll be sketching with examples. So I'll be going through all of them in a chronological order, starting with linear graphs, linear functions. So what you're used to seeing, the form, I'll write over here, y equals mx plus c, where we should all know that m is the gradient and c is your y-intercept. So this is a refresher for everyone. Now, if I give you guys an example, 2y plus 3x equals 16, the first thing that you should be thinking, so I'll write my steps over here. So these are your steps as you're drawing these graphs. Step 1, get it into a form that you understand. Get into right form. So with this example over here, you can see that it's not in the y equals mx plus c form, but really we're only taught how to sketch according to this form. So I need to rearrange the equation. So to get y by itself, move the 3x to the other side. So you get 16 minus 3x. You have a 2y here, and it's 2 times y, so obviously you divide it. Now you get negative 3x over 2 plus 8. Does that make sense for everyone? Okay. Second step, what is gradient? It is m. So obviously, I'm just going to write it down quickly over here. My gradient is negative 3 over 2. And then your y-intercept, you can see clearly, it's just 8. And then what's special about this is the reason why I say what is the gradient is because a lot of students, sometimes they just see the gradient and they start sketching, right? They get into this form and then they sketch. But the thing is, you need to be aware of, okay, if it's a positive or a negative graph, because this gradient here is negative. So when it comes to knowing whether it's positive or negative, if it's positive, it should be able to form a tick perfectly. That's how I remember. This is a positive graph, okay? It has a positive slope, and the other one, obviously, you can't form a tick. So I just like to keep that in my head because so many students make mistakes here. Oh, Jesus. Anyways, after you've got the gradient down, this is pretty straightforward to sketch. You've got your y-intercept is 0, 8. So what I like to write is y-intercept. Always write the step. Y-intercept is when x equals 0. This is pretty straightforward because this would turn into 0. So you have your y-intercept is just 0, 8. And your x-intercept is when y equals 0. So always write this step, because this is a mark in VCE. And once you get your x-intercept, you have to make the equation equal to 0. So what I like to do is 0 equals negative 3x over 2 plus 8. Now rearrange, you get negative 8 equals negative 3x over 2. That's negative 16 equals negative 3x. 16 over 3 equals x. Okay, that is your x-intercept. So I'll write down the coordinate as well, because sometimes people get confused with coordinates. Now, it's really easy to sketch. You just 0, 8, and then my other coordinate is 16 over 3. Oh, what's that? 5, so around here. So you have 16 over 3, 0. And once you do that, you can just connect the dots, and you'll realize, okay, it's a negative slope that matches with my gradient. So after you get your y-intercept, oh no, that's the wrong color. You have to find x, y intercept with this step. Always write this down so you can get that working out mark. Does that make sense? Okay. Take a screenshot of this. Now, next one. Obviously, after linear, we're going to go on to parabolas. So parabolas / quadratic. Okay, so we know the basic graph of parabolas. If it's positive, it looks like this. So they say smiley face, and if it's negative, it looks like this. Sad face. So this is a negative parabola, this is a positive one. And there are two forms. Let me just write down the forms. there is y equals ax squared plus bx plus c. This is your standard form. Okay, and then the other one is ax minus h squared plus k. This is your turning point form. Okay, so make sure you familiarize yourself with these two forms. Can they even see that? Okay, let's continue. So, for an example, I'll give you guys this one, x squared plus 6x minus 10. So, if I'm given this as a function to sketch, I need to think, first step, there's my marker. 1, what form is it in? Form is it in? Okay, so obviously this one is standard form. But after you identify what form it is, refer to this diagram. So your first question is your form. So there's two forms, there's standard or turning point form. And if you're at standard form, ask yourself, can I factorize? Can I factorize? And then if the answer is yes, obviously factorize. So then you get it into a form that looks something like this. You'll get maybe an a outside, your dilation, x minus b, x minus c. And this becomes intercept form, and it's easy to sketch because all you do is you find, okay, at what values are the intercepts? So say b is here and c is here, and then you can sketch, right? But say you're stuck with an option where you actually can't factorize. So if you can't factorize, no, then you have to ask yourself, okay, what else can I do at this point? So yes, you find x-intercept, find y-intercept, sketch. Okay, if you can't factorize, what you have to do is complete the square. Let me just complete square to get it into turning point form. Okay? So what you're able to do is, if you complete the square on this, you can get it into this form. And then from here you find the turning point, which is shown to you inside the form itself. And then find y-intercept, find x-intercept, and then you sketch. So in your head, you should be going through all these steps. Okay, what form is it in? And if it is in this form, can I factorize? Always ask yourself this first, because a lot of students forget this step. If you can factorize, find x-intercept, find your y-intercept. Okay, and I'll go through this as well. Find your turning point, and then you can sketch. If they ask for a turning point, sometimes they just tell you to sketch the function without having to identify what the turning point is. But you'll realize the x value of turning point, when it's in intercept form, is the midpoint between two of the x-intercepts. So for instance, this is just referring to standard form, by the way. I have a graph where the x-intercepts are at, let's say, -1 and 5. Okay? And it's a positive graph, so it looks something like this. Okay? And I want to know what the turning point is. So the x value of turning point is just the midpoint between these two. So all you have to do is -1 plus 5 divided by 2. This is your midpoint formula. Just think about the middle number between these two, which is just 2. So I know that at this point the x value is 2. And to find the y value, to find the height, you have to sub it back into the function. So say the function was something like this, x minus 5. Then all you have to do is sub it back into this equation, and you should get your y value, or your height will be 2 plus 1 is 3 times 2 minus 5 is -3. So it's 2, -9. Okay? Does that make sense? So this is just an off to the side. This is how you find the turning point value. Okay? Now going back over here to your turning point form. Actually, let's just go straight to our example. Okay, so if you look at this example, obviously you think form, standard. Can I factorize? Now, one special case here is there's a negative here, and we don't really like dealing with negatives, so I'm just going to get rid of that. Put that outside the bracket. It doesn't mean I just chucked it away. I'm just putting it outside the function x squared minus 6x plus 10. Can I factorize? 2, 5, 1, 10. So no, the answer is no. So what do I have to do if I can't factorize? I need to complete the square to get it into turning point form. And it's perfect that we took out the negative, because every single time you try to complete the square, always make sure that the x is by itself. It's lonely. There's no number in front of it. There's no negative sign in front of it. So what you should be able to do is complete the square, follow my steps. X minus 3 squared minus 9 plus 10. And this is all inside the bracket. And let me just give you a quick reason why we complete the square. So every single time you're completing the square, you just think, okay, I want this blue bit, x squared minus 6x. And if you expand this, you actually get x squared minus 6x plus 9. So try this out for yourselves. Expand this. So you should get x squared minus 6x plus 9. And the reason why we do minus 9 at the back over here, this little bit, why you subtract the 3 squared, is because, look, these two cancel, and then I drop down the plus 10. So what I've done is I've gotten the same expression as this entire thing over here. Okay, so that's why we complete the square. It's essentially, you're just changing the form. You're not really doing anything to the equation. You're just changing the form to get it into the turning point form. Okay, so after you've done that, your expression, it's a bit messy. Your expression is now y equals negative x minus 3 squared, big bracket outside. So this is obviously plus 1. Now, we don't like this form, because if you look at our turning point form, there is no extra bracket. Okay, so what I'm going to do is expand it, negative x minus 3 squared minus 1. Okay, so this is now a sketchable form. So, I don't want to erase it. Okay, we'll just do this then. So obviously the function before was x equals negative x minus 3 squared minus 1, right? So first step, oh, you can't see it. Okay, anyway, first step, if you refer to the diagram that I had on before, is you have to find the turning point. So step 1, what is the turning point? So obviously your turning point here is 3, negative 1. So remember, how I like to think about it is every time something is in a bracket, use null factor law. So we know that when it's to do with the x's, you take the negative of it, or you make it equal to 0 and you get 3. And then the y value stays the same for the turning point. Okay, I can go into, I'll just ask comments down below if you're confused. Now the second step is you need to find the y-intercept. And so make sure you write this step. Y-intercept is when x equals 0. So all I have to do is sub in x equals 0. That is negative 9. Oh, oops. That is, you write down 0 minus 3 is negative 3. Squared minus 1 equals negative 9 minus 1 equals negative 10. So your y-intercept is 0, negative 10. And the reason why I don't find the x-intercept first is because if you look at it, I'm going to start visually like imagining what the graph will look like in my head. So my turning point is at 3, negative 1, and it's a negative graph. So remember, negative graph, sad face or angry face, whatever you like to remember it as. And once you've got the turning point, 3, negative 1, okay, it's going to concave down, and your y-intercept is at 0, negative 10. You'll realize that you don't actually need to find the x-intercept. So that's why I say find the y-intercept first, because you won't be able to solve for an x-intercept, okay? So that's how you sketch the parabolas. Now let's move on to some other ones. Okay. Another one that we have, so we've done linear, parabolas, now we will move on to cubic. Honestly, you get to a certain point where you can sketch cubic, quartic, I don't know, any polynomial to whatever power if you can get it into a certain form. So I'll give you guys an example. So obviously cubic is in no, not this color. So we've got ax cubed plus bx squared plus cx plus d, right? But really, if they ever ask you to sketch a cubic in VCE, it's going to be in like an intercept form. So I'll just jump straight into an example. Y equals let's give an easy one first. 3 times x plus 6 squared. Okay, so if you get something like this, you'll have to relate it back to what we learned in terms of parabolas, and you'll be able to realize that if you were to find the x-intercept, which is when y equals 0, so this is always the first step. Oh no, first step is if you have to get it into this intercept form. So let me write the steps on the side. Steps. So 1, get it into intercept form. Move this out to the side. Intercept form. So that's where it looks something like this. We'll do b x minus c. It might be x minus h squared, whatever. So this is for any parabola to whatever, like it's any degree polynomial. Okay, so for x-intercept is when y equals 0. Well, obviously by using null factor law, we can see x plus 6 squared, your x-intercepts are 3, 0, negative 6, 0, right? But you realize that this is a turning point and relate to the basic function of the graph. So what does a basic cubic look like? So it looks something like this if it's positive, and it looks something like this if it's negative. Okay, or you'll see ones that also look like this, and ones that also look like this. So this is if you have like x cubed. There's like negative x cubed, but these ones are in like intercept form where it hits the x-axis like a certain amount of times. Okay? So if you go back to here, we have 2 points. And you'll realize that this is actually to the power of 2, right? Then you relate to your turning point form. So I know that at point negative 6, 0, there's actually a turning point here. And at 3, it just cuts the x-axis. So it just goes through it, like these points here. Okay? So what I mean by that is I will now relate it to a graph. So if it's a negative graph, in my head, I'm going to think it's going to look something like this. And the common thing is that you can think, okay, from the left, it's going down first and then, you know, doing whatever afterwards, right? So I think, okay, I'm going to start by going down first. But I also know that it's a turning point, so it has to turn at that point. So I'm going down, turning up, and then whatever, go through and cut my x-axis here. Does that make sense? So at this point, I'm turning. It's a turning point. I make it a turning point. And then here, I just cut. You probably should find your y-intercept as well beforehand. So we'll just quickly do that. Y-intercept, x equals 0. Make sure you write this. This is a mark. So when x equals 0, so much. Y equals negative 3, 36. So the answer is plus 3 times 36, which, oh my god, okay, 108. So this is very off scale, but it is 108 here. Oops. 0, 108. Okay? So that's how you sketch these sort of graphs. Okay, so that is how you sketch cubic graphs. And it's the same thing, like even if I have something like y equals, let's say, x plus 2 squared times x plus 1 times x minus 4, right? So this is to the power of 4, right? X squared, x, so you have x to the power of 4 in total, right? So it's what you call a quartic, so it looks something, it ends up looking like a parabola. So this is x to the power of 4. All even functions, so if you have like x to the power of 6, look basically very similar to the parabola, except they're just getting more and more, I guess, they grow quicker, okay? So this is x to the power of 8. Whereas x to the power of an odd term, x to the power of 5, is going to look the same, but they're just going to grow quicker as well because you're, you know, doing timesing more of it by itself. Okay, so let's do this one quickly. I'm just going to sketch it. I'm not going to do the x-intercepts or anything, y-intercepts or anything. So I know at -2 there's a turning point, -1 there's a turning point, and 4 there's a cut. And now I think, okay, this is a positive quartic, so that means I start from here. Let's keep it on. Let me just make it a bit bigger so you guys can see. It's a quartic, so it looks something like this, right? And it's positive. So I'm going to do a turning point here, and then, is that right? And then turning point here, and then cut. Oh no, that's not a turning point. Sorry. It should be a cut here because it's only to the power of 1. So it'd be cut and then cut. What I did there was something else. So does that make sense? At -2, I know that there is a turning point, so I'm going to turn it into a turning point. -1, you're cutting it. So you're just going straight through the graph, and then you're just following along, really. So get some practice of this by yourselves, because it all comes with practice. Okay, we're finally out of the... So we've done all of the linear, parabola, polynomial stuff. Let's get into... let's do square roots. No. Yes? No. Yeah, okay, square root function. Square root function. So we know this as this, right? This is root x. And one thing that you guys should always learn first is what the reflections look like. So actually, let me do this side first. So if I want to reflect in the x-axis, I am going to put a negative outside the function, okay? So this is outside the entire function. Do you see that? And then, since I'm reflecting in the x-axis, imagine that there's like a mirror here. All I'm doing is, can they see? Flipping it down, okay? So that is the square root function reflected in the x-axis. Now, imagine if I want to reflect it in the y-axis. So reflect in x-axis. Okay? And then this is reflect y-axis. If I'm reflecting y-axis, I have to put the negative inside the function. So this is a huge differentiator. If it's outside the function, you're thinking x-axis. If it's inside the function, you're thinking y-axis. And so this time, your mirror is at the y-axis, and then you flip it across, and you get something that looks like this. Alright? Now, you guys should be thinking, okay, what the hell do I put here then? What does this graph look like? What is the function for this graph? Well, if you think about it, you flipped it down this way, and then you flipped it across this way. So you flipped it across the x-axis, and now you're flipping it across the y-axis. So really, what you've got here is a reflection both ways, so you get negative x. So you have outside is your x-axis, inside is your y-axis. So it's pretty simple to remember, okay? And the special thing about square root functions is that they do have like a restriction, because, so always keep this in mind, you can't square root a negative number, okay? So just do star as a number. You can't square root this. So you have to keep that in mind within sketching, that there is a starting point with square root functions. So I'll give you guys an example here. Let's do a hard one. Negative root negative x plus 9 minus 2. Okay. So this is our function that we want to sketch, okay? Bring it in closer so you guys can see. So what I'm going to do first is I'm going to expand it. Y equals negative root negative x plus 9 plus 2. Okay? So they will give you these sort of trick questions where there's a bracket in front, and then you're supposed to expand it to get it into a form that you can actually sketch. Okay? So when I think about the starting point is I'm going to make this expression inside equal to 0, because we can't go any less than 0. Like, I can't have a negative number inside here. It has to be greater than or equal to 0. So obviously, inside the bracket, x plus 9, well, the only thing you can do to make it greater than 0 is when x is greater than negative 9. So x has to be greater than or equal to negative 9. Oh, negative 9. And then you have your plus 2. Well, if I know that if you square root any number, it cannot be less than 0, then the greatest that we can have, the biggest y value that we can have, or the smallest y value we can have, sorry, is if this entire expression is equal to 0. So my starting point is at negative 9, 2. Okay, that might be a bit confusing, but you'll see once we start sketching. Okay, so I'll just go through what is going through my head. So the first thing is if I have a function that's like root x plus 4. I'm going to do easy versions first and then go into the hard stuff. So if I have root x plus 4, well, I know that root x starts here, but I'm moving the graph up by 4 units. Think of it as translation, right? Okay, and then since it's a positive graph, all I'm going to do is go this way, right? Just the basic function. And the reason why another way I like to rationalize, okay, is root x, the smallest that it can be is 0, right? So therefore the smallest y value it can be is 0 plus 4, which is shown over here. So this is my starting point. Now if I have another function, if I have x minus 2, well, what's the biggest value of x that you can have? I mean, the smallest value of x that you can have? Well, it has to be 2, right? Because inside this bracket, inside the square root, it can't be less than 0. So my starting point, so there's no up or down translation, is at 2. And then it's just a basic graph out. Or other people would like to think of this as translations, right? You can just see when it's inside the function, I like to think of it, okay, I need to do the opposite, null factor law. So this shows me that is a translation 2 units to the right in the x-axis. And then this one is just translate 4 units up. So when you're dealing with translation along the horizontal, it's going to be the opposite, or use null factor law to be able to help you sort that out, okay? Alright, now let's go on to the hard graph that we have here. We've established that the turning point is negative 9, 2. So once again, I'll just quickly go through it again. That's because this expression inside the bracket has to be equal to 0, or you can think of it as, okay, it's x plus 9. So that means it translates 9 units in the negative direction of the x-axis, or 9 units left on the x-axis. And then there's a plus 2, that's just translate 2 units up of the original function. So you start here, original function, you go 9 units to the left, 2 units up, you go here. And then look at the graph. Okay, there's a negative and a negative. So I relate it to this graph, and all it's going to look like is something like this. I know it's off the page, but that's the main point of it. So it's negative 9, 2, and then it goes that way, following this. Okay? Once again, sketching graphs just takes a lot of practice. So try to get the basic understanding of it. You have to sort of understand translations at this point to be able to sketch them effectively. But it's all about practice anyway, so get that down. Okay, let's see, what else is there? Which one should I go through next? Okay, fine, I'll go through exponentials. Exponentials. So we know these ones as like e to the power of x. Sometimes they give you 2 to the power of x, like a random number to the power of x. The point is, it's to the power of x. And the basic function, just think, okay, e to the power of x, you're growing. Okay, so think of what things sort of grow in exponential functions. In textbooks, they always give you like, oh, the population of rabbits is growing by this exponential function right here. So just think, over time, as time goes on, there's a lot more bunnies, okay? And then there's the other one that's decaying. Decaying. E to the power of negative x. And once again, when I think decaying, okay, it's like just a population dying out. That's what I like to think of. And you'll realize if you relate it to the square root concepts before, you can see the reflection, right? So this is obviously flipped across the y-axis. That's why there's a negative inside the function. So think of the function e to the power of x. You can see that inside the function is at the negative x, okay? Whereas if you want to flip in the x-axis, so negative x, it will look something like this. Okay, e to the power of, oops, negative e to the power of x. Alright, and one thing that I would like to say, Jesus. One thing that I'd like to say is there's actually the special part of this is that there's really an asymptote here. Is that x equals 0? Y equals 0. Y equals 0. Because if you think about it, you can chuck in any number into the x. So we're working with this function for now. You can chuck in any number in here. But the thing is, you'll never get 0. So you can put in like negative 2. It will just be 1 over e squared. That does not equal to 0. You can chuck in e to the negative, like, you can chuck in e to the 0. It will give you 1. Okay, so you can't actually get 0 from this expression, and that is why there is an asymptote there. Okay? So that's something to think about. So same sort of concept as before. Start trying to link the concepts. Okay, I've taught you square root functions. You can see how the reflections work. Exponentials, it's the exact same thing as well. Okay? So really, exponentials aren't super difficult. You just have to relate to translations as well. So if I were to tell you to sketch e to the power of negative x plus 4, and then there's like a negative 1 here. What I would do is, now you're starting to think in terms of translations, I will get it into a form that I understand by getting x by itself. Always get x by itself. So take out the negative, x plus 1 plus 4. So this is inside the function, therefore I'm dealing with translation inside the within the x-axis, right? So if it's a plus 1, that means I know you're moving 1 unit to the left on the x-axis, and then your y value plus 4 is moving the graph up by 4 units. So remember how there's an asymptote at y equals 0, all I have to do is move it up by 4 units, y equals 4, right? And now I know that, so I'm not looking at the reflections yet, I'm just looking at the translations first. I know that I'm moving 1 unit to the left. So now I'm going to look at the translation. This is a negative 1, e to the power of negative x. So I know the basic graph looks like this, decaying, right? So all I'm going to do is follow that curve down this way. This is the basic shape in my head. Oops. And then what I'll do next is find y-intercept is when x equals 0. I'm not going to find x-intercept because I don't need to. Like you can see just from the shape of the graph, it won't touch the x-axis, so there's no point. So y-intercept is when x equals 0. So all you have to do is e to the power of negative 1 plus 4. That is 1 over e plus 4. Now, in VCE, sometimes you have to approximate. You have to guess like approximately what this value is. If you think about it, if e is 2.27 or 2.7 something, I don't remember, 2 something, right? Ooh. Then this is like half plus 4, so that's like 4 point something. So I'm just going to write over here like 0, 1 over e plus 4, that's my y-intercept, and then follow the shape of this graph. It looks something like this, and you're approaching the asymptote. Okay? Now, let's move on to the inverse of exponentials, which is logarithms. Oops, why so ugly? Logs. Okay, this is very similar as well, except the reason why they're inverses is because you're actually reflecting across the y equals x line. So if you have an exponential that looks like this, your log will end up looking something like that. It's a bit messy, but you guys get the point. Okay, anyways, that's how they're related. Now, obviously the function, it looks something like log e of x, y equals log e of x, and then your function looks like this, except remember you're swapping the x and y every time you're doing inverses, so your y equals 0 asymptote now becomes x equals 0. And if you think about it, it makes sense because you can't put 0 into this function for it to make sense. You can't log 0 because e to the power of something will never be 0, okay? So this is your log e of x graph, and then if you reflect it, same sort of thing, negative log e of x. So this is outside the function, therefore it's a reflection. Ooh, no, my bad. This is inside the function, therefore it's a reflection across the y-axis. And if it's outside the function, log e of x negative, then you just have to reflect it like down, so it looks something like this. Okay, so you're just playing with reflections over here. Let me just sketch graph. So the first step with these sort of functions is just to work out the asymptotes. So if my graph is log e of 2x minus 3, let's do a negative here, plus 4, let's do a negative here. Okay, so big function, but we're going to break it down step by step. So obviously, first step, get rid of the bracket. Negative 2x plus 3 minus 4. Okay? So I've expanded it. Oof. Now, I start thinking about this component. What I like to do is literally, okay, if I know that this can't be 0, right? Then I know that the asymptote is when I make this expression equal to 0. So what I'm going to do, the asymptote is when I make this expression equal to 0. So you get negative 2x equals negative 3, x equals 3 over 2. So I know at this point that my asymptote is at x equals 3 over 2. Okay? And then you literally just, and then you just look at the function. But another way that people like to do it is they take out the negative first. So they see it as, they take out the negative 2 first. So there's two ways to do it. It's either you make the whole expression equal to 0, or you take out whatever is in front of the x. You get x by itself, right? So you get x minus 3 over 2. And you realize it shows you that the translation is moving 3 over 2 units to the right. So they give you the same answer. Okay, they're doing the same thing, but this one shows it to you more in like it's better for if you have more intuition with dealing with translations, right? So there I've got my asymptote, right? And then I think, okay, there's moving 4 units down, sorry. So you have to factor that in, and then I look at the graph, there's a negative here and there's a negative here. So in my head, I'm going to look at the basic graph, now flip, and then flip, oh my god, like this. So your function should look something like this, okay? In my head, I'm thinking, okay, my graph should look like this. Now I'm going to find the x and y intercept. So x-intercept is when y equals 0. So I've got move 4 to the other side. 4 equals negative log e of negative 2x plus 3. Move it to the other side. Negative 4 equals log e of negative 2x plus 3. Now, use your log exponential practice. E to the power of negative 4 equals negative 2x plus 3. E to the negative 4 minus 3 divided by half equals x. So this is your x-intercept. So check that on the calculator, whatever that is. Okay, sorry, I just realized that I made a mistake over here. I wrote down negative 2x minus 3, but in my head I put a bracket around this, so when I expanded it, I got negative 2x plus 3, okay? So we're sketching negative 2x plus 3. Okay, and then my x-intercept that I got before was approximately 1.49 something. And now I'm going to find the y-intercept is when x equals 0. So I'm just going to, once again, make this expression equal to 0. So you get negative log e3 plus 4. And it will be somewhere around here. Okay, and then that's what your function should look like. Okay, so find what that is approximately on the CAS and then just sketch it out as usual. Okay, so we've done logs, we've done exponentials. Now just 2 more graphs. Okay, so the last 2 that we have is I always struggle saying this, hyperbola. Hyperbola, is it spelled like this? I have no idea actually. How do you spell hyperbola? Hyperbola. Yeah, it's with the A, sorry. Hyperbola. And obviously the basic graph that we know is y equals 1 over x. Looks something like this. And I'll explain the shape of this graph, okay? Oh, there's also two asymptotes. X equals 0, y equals 0. Okay, let's explain the asymptotes first. You want to understand this graph intuitively. It makes things a lot easier. So why is that an asymptote at x equals 0? Well, if you sub x equals 0 into here, it doesn't make sense, does it? Because you get y equals 1 over 0. And 1 over 0 is invalid. You can't divide anything by 0. So that's why there's an asymptote here. And now, if you think about it, if I know that, okay, I can't sub 0 into this, you will know that 1 divided by whatever, any number in the world, it will never give you 0. So that's why there's a y asymptote over there as well. Okay? Whatever you divide by, you won't get 0. So there's two asymptotes there. Okay? Now, have a think about why the graph's shape is like this. So let's work in the positive quadrant, right? Your value, your function is 1 over x. Think about it. Okay, the larger the x values go, because these are your x values, right? The larger they go, the smaller the y value, or the smaller the height is going to be, because say you go to like 1,000, your height is going to be 1 over 1,000, right? And that's very, 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 very small. So that's why as you go on, the height actually approaches to 0, okay? It's a bit messy, but the point is it's a smooth curve approaching 0. And now if you think about it, if you get very, 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 very close, where x is very, very close to 0, so over here, see how you're approaching 0? That's an arrow, by the way. See how you're approaching 0? Well, if I make x equal 1 over 1,000, so what you're subbing into here, you get 1 over 1 over 1,000. That turns into 1,000. So the smaller x values, so you're dealing with x as small fractions now, it's going to make your height grow a lot taller. So that's why it's higher or near when x equals 0 and lower as x approaches infinity. And it's in the positive quadrant because you're doing 1 divided by a positive number, right? And then over here, the x values are negative, so that's why your height is negative. And the same concept applies, okay? And now all you have to think of, there's only one graph that you have to deal with, the reflection-wise, it's negative 1 over x. Because if you think about it, if I reflect, okay, in the x-axis, I'm just putting the reflection outside the function, right? But if I am dealing with reflection in the y-axis, once again, I put it inside the function. But both of them is the same thing as 1 over x, just negative the whole thing. And you'll realize it makes sense because if you flip, okay, across the x-axis first, you'll get this graph. Even if you reflect across the y-axis, you'll still get that graph. And then, if you reflect it both the x-axis and the y-axis, you'll get the original function back. Okay? So let's sketch one of them. Where's my pen? Let's sketch. Let's do a hard one. No, okay. Yeah, let's do a hard one. No, I won't do a hard one. Oops. Let's do 1, negative 1, x plus 2 minus 3. Okay, let's sketch this graph. So, I like to say, when you're dealing with hyperbolas, just think about moving the asymptotes, okay? So, obviously this can't be 0, right? So, I know that x can't be 2. And then, as a result, if this expression can't be equal to 0, the other asymptote is, so asymptote, y equals negative 3. Because this can't be 0. So, the asymptote that's left over is negative 3. Or you can just think of it, okay, as I'm shifting the original function, shifting it down by negative 3, down by 3, and then this one is moving left by 2. Okay, so your asymptotes should be, negative 2 over here. X equals negative 2, and then shifting down by 3, y equals negative 3. And now you just have to think, okay, is it positive or negative? Well, this graph is negative, so it looks something like this. Looks something like this. And then you should be able to find, so your x-intercepts and y-intercepts, okay? This is very simple, just do it by yourself. I'm a bit lazy right now. And then last graph that we have is Truncus. Same thing, related to the hyperbola, Truncus. The basic function looks like this. 1 over x squared. And then the other one looks like this. Negative 1 over x squared. And there's no reflection in the y-axis because if you think about it, if you put the reflection in the bracket, inside the function, this just becomes this, okay? And you'll realize it makes sense because it's symmetrical. So even if you reflect it across the y-axis, it will still be the same function again, okay? Now, let's just do an example. Let's do a hard one. Okay, y equals 4x over 2x cubed plus 12x squared plus 18x. Okay, sketch this. And yes, trust me, this is a truncus. You just have to think about getting it into the right form, as I always mentioned before. So, the first step, when you get such ugly numbers like this, what do you think? Okay, can I simplify this in any way? So, I'll realize that, okay, there's an x that I can take out, and also these are all divisible by 2, so that's my first step. So I'm going to take out the 2x, so now I get x squared plus 6x plus 9, okay? And you realize that I can actually cancel these, so now my function is 2 over x squared plus 6x plus 9. Okay, but this isn't in my truncus form yet, until I realize that this I can factorize. So that becomes x plus 3 squared. And now I can start sketching this. So I know that there's a dilation here, but I'm not going to deal with that right now because it factors in when you do the x and y intercepts. So I know my basic graph looks something like this. But this time I have a left-hand movement in the x-axis because I've got a plus 3, right? So my asymptote, I'm going to move this, there's an asymptote here, x equals 0, same thing, y equals 0. Same reasons as before, dealing with the hyperbola. So now I'm going to move my asymptote 3 units to the left. So I get x equals negative 3. So now, after I've moved it to the left by 3, I will also realize, okay, the y asymptote stays the same because there's no up-down movement. Now I'm going to try and find the y-intercept when x equal to 0. So all I have to do is sub in 0. So I get y equals, it was 2 over 0 plus 6 times 0 plus 9. So my height, where it crosses the y-axis, is 0, 2 over 9. So this is 0, 2, 9. And that's it. Yeah, that's it. Okay, so everyone should go home, practice all of these because I can't go through everything in a YouTube video. So make sure you focus on understanding translation, reflections, and just practice going through having this step-by-step process when you're sketching graphs, and then naturally it becomes easier. And you'll realize a lot of the graphs that we sketched today are actually related to each other, and it makes it a lot easier if you can just go through all of them at once. Try to understand each graph well, and naturally the other ones will become easier, okay? Thank you guys for staying with me.